So Roboy, as it is here, came to be as the birthday gift of the 25th anniversary of the Laboratory for Artificial Intelligence at the University in Zurich. We wanted to build a very unique robot, and Roboy is unique in as much as it doesn't only look like a human, roughly, but it also copies the way we function, and that means it has muscles instead of motors in the joints. And what we do is we try to understand how the muscle control creates the motions that we can do, creates more natural motions. What are the upsides of doing it like this instead of the traditional way? So I became project manager of the Roboy project at the point where Roboy was first presented to the larger publicity. And because Roboy has been developed in only 9 months, and because of that we had to work with a lot of companies, and this also meant that we have a lot of contracts that we had to fulfill where Roboy went to some events and so on. So I basically organized that this is happening. Well, of course, walking in itself is extremely challenging. Walking with a system like Roboy is even more challenging because it's a soft system and you need to measure all these movements that are happening. So the advantage of building a system that is built like Roboy with muscles and tendons, so in terms of if you want to build a very able robot, it's maybe not the best approach. Then you want to take the standard way because there's a lot of optimization that has been gone into it. But we think it's extremely interesting, for one, because it tells us a lot about how it works in humans. There are some interesting properties that we don't see in other kind of systems. So the systems are very light, they're inherently safe. So Roboy, basically you can just push him back if it's in the way and so on, but you couldn't do that with an industrial robot. So even if he's off, he's kind of not a hazard. Another important point is that we can show behaviors like muscle pre-tensioning. So when we throw a ball, for example, we contract all the muscles in our torso, and then not only release the ones on the frontal torso, and that's the reason why we can even throw a ball more than a few meters. So basically you store energy in the muscles, and that's something we can show in these kind of systems as well. It's just a very interesting route to explore, and with not necessarily having like clear upsides in terms of application as a product or so.